Ladies and gentlemen, it's my pleasure to welcome you here to the RGS tonight for this event to support the International Commission for Zoological Nomenclature. You're all very welcome. Before we start tonight's event, I hope you'll just indulge me for a couple of minutes. And I want you to imagine a world where there were no nouns, no way of naming objects. How hard would it be to have a conversation and to convey any real meaning or to be understood by somebody else? And how long would our sentences need to be to describe a simple experience? What if our use of nouns was inconsistent, where there were no conventions or common understanding of what individual nouns mean, or people opted at their own discretion to name new things with words that already exist? And I don't mean the minimal confusion of the sort, I say tomato, you say tomato, but something more fundamental. The sentence, I drink gin from a tumbler, is simple enough to understand and fairly unambiguous, unless you consider that gin is a form of trap and tumbler is an acrobat. I drink trap from an acrobat doesn't convey anything sensible at all. Nouns, the context in which they're used, and a common understanding of their meaning are essential for any kind of discourse. Likewise, our understanding of species requires that we can identify and name organisms consistently, and there needs to be a set of rules to govern how names are adopted, maintained, and remain unique. To oversee naming of species in the field of zoology, ICZN was established in 1895. It publishes the code or set of rules that govern the naming of new animal species, and it rules on areas of contention or confusion for the common good. Throughout the first half of the 20th century, all was well. ICZN was effective, and publication of the code and the bulletin, whereby cases were considered and resolved, provided more than enough financial support for the Commission's activities. However, the world has changed. Zoology as a discipline is more fragmented, the way scientists access basic scientific information has changed, and there is far more scientific research to be disseminated. So tonight's event has two objectives: to reconfirm the importance of a stable nomenclature as a basic requirement of being able to study and disseminate information about the animal species we share the planet with, and to highlight the ongoing need for money to contribute to the work that ICZN undertakes on behalf of the worldwide community of researchers who study animals. But you didn't pay good money to listen to me tonight, so without further delay, can I introduce our two eminent speakers, Professor Richard Fortey and Sir David Attenborough. Thank you very much.
Well, good evening. Can you hear me? Can you hear me now? Yes. Good. I thought I'd start right at the basics about names. You've heard some of this from Mike Dixon already, but there is currently a big effort to name the organisms, the living organisms that we have in the world. It comes as a surprise to many people that we still don't know. We're still woefully ignorant about a large part of biodiversity. The names are an absolutely essential part, the first handle that we get in communicating not only with fellow scientists, but with members of the public about what we have. One of the greatest living biologists, E.O. Wilson, patron of the ICZN, said, the beginning of science is the description and naming of phenomena. It lies at the very base of everything we do. If you get the names wrong, you're going to get the science wrong. Just a little bit of history. If you go back to the early days, we didn't have the convenience of scientific names. What we had instead for a given animal or plant were kind of abbreviated descriptions. that tried to put all the characteristics in a sentence that the plant or animal had. These are animals, in this case, birds. So the things in red are the handles by which a scientist, or indeed a member of the public, would know these particular animals. And as you see, they're extremely cumbersome. It's much handier to have a scientific name consisting only of two parts, usually, a genus and a species name. Homo sapiens is the one that's familiar to everybody, our own Latin name. But the same principle can be applied across the animal, indeed plant kingdom. It's a unique system of labeling which enables us to know exactly what we're talking about. Of course, it seems pretty trivial in the case of Homo sapiens, but given the huge range of species there are in the world, it's absolutely essential. The system that we now use, of course, goes back to the great Carl Linnaeus, or Carolus Linnaeus to Latinize him, and his Systema Naturae. Linnaeus brought nomenclatorial order to a chaotic world. He dispensed with those rather elaborate descriptions, and although he gave descriptions of species, he attached each one a simple generic and species name. He organized things into a hierarchy that could be used by his fellow scientists and students. He was an enormously systematic man. He tackled animals and plants in great variety. He left fungi for some reason, but there was another Swede called Elias Fries who did for fungi what Linnaeus did for plants, and indeed animals. Now we have to have an arbitrary starting point for our names, before which we don't accept names as legal, and the works of Linnaeus are quite rightly taken as that kind of fundamental starting point. There are common names, of course, which are also used by serious naturalists. This is the Glanville fritillary, a butterfly, one of a group of very similar-looking creatures, rather beautiful, and it's named after a lady called Eleanor Glanville, who was a butterfly enthusiast. And it is not actually its Latin name. Neither Glanville nor Eleanor are in the Latin name, but it's an extremely useful way of talking among your fellow naturalists about a particular species of butterfly. So what we're talking about are not common names, not varietal names or breed names, we're talking about species names. Why do we need such a careful use of Latin names? Well, common names can mislead. Glanville fritillary happens to be fine, but this is just one particular species of luminous click beetle with a very, very wide distribution around Jamaica, the blobs. And those blobs show its local name, some of them I think rather charming. Peeny Winky, I like that. Moonshiner, I like that. There's a lot of poetry, of course, in common names, which you might say the Latin names sometimes lack. But you don't need me to tell you that it's actually, if you know it somewhat less elegantly perhaps, as Pyrophorus plagiophthalmus in all localities, you're not going to suffer any confusion. One person from one side of Jamaica is going to know what they're talking about when you talk to somebody from the other side. Local names vary very rapidly. What you need is a common language that really identifies the organism accurately. Or take the case of the elk. Well, on the left, we have the European elk, and on the right, we have the American elk. If you talk about elks in North America, that's what they'll mean, but they're two utterly different species. And the Latin names, of course, Alces alces, as opposed to Cervus canadensis, help you to pinpoint which species you're dealing with. There's no ambiguity in that language. So just at the very basic level, it gives you an accurate label to pin on something in nature. Well, what's the problem, you might say? Well, the problem is that there are so many animals. This is the whole of the natural world at the top there. I love plants, but there are 260,000 of them about. Species. Animals, 1.18, perhaps rather more on many estimates, because we don't know what there is, really. But there are a lot of species, and that's a lot of names. And it's not surprising that if you've got a lot of names, you've got the potentiality for confusion, particularly if you've had a history of nomenclature going back for, as we have, a couple of hundred years. It's not surprising that confusions have happened. Well, of those animals, of course, the insects make up the lion's share. So entomologists are particularly enthusiastic namers of things and revisers of things. And of the insects, the beetles are notoriously biodiverse, and plenty of energetic people have spent their entire lifetime working on one subfamily of one family of one order of beetles. Every time you turn a log over in a tropical rainforest, you seem to find a new species of beetle. Bees, wasps, and ants are pretty diverse as well, and so are butterflies and moths, but we're talking tens of thousands in these cases. So there's a huge job to be done, and it's not surprising that we need laws and rules to keep things in shape. And that's what the ICZN does. It makes sure that names are valid and do not apply to more than one organism and are in the correct form. That's a sort of traditional way of looking at insects, perhaps. But these days, having computers available has lent an entirely new dimension to the way we do taxonomy, and it's made an enormous difference to the amount of information that can be stored, and it's made an enormous difference to how we communicate with our fellows scientists around the world, and indeed how amateur naturalists manage to communicate with one another as well. It really has transformed the kind of information systems that we have. If you've got 1.8 million species, you've got an awful lot of information, but computers can handle it. So there we are. Systemae Naturae, Linnaeus' work with 4,398 species in it on the left. A CD, a catalogue of life here on the right, and you can get it all, list of 1.25 million species on the right. But of course, you're going to say, well, what about the other 0.6 million? They're probably not listed or correct, or they've got problems. And this is just one of those slides one is obliged to put in to show all the different users of names. Names, rather like a telephone directory for getting your way around London, are the basic way that people communicate their scientific information about biology. And that's it in a nutshell. Well, what sort of problems does the ICZN tackle? Let me give you a couple of quick examples of things that go wrong. In this particular case, two species were named, and they look very different. This chap on the left, that chap on the right, very, very different color patterns. They were given two different species names, and not surprisingly, it was discovered later on that they were just male and female. It happens. So one of the names has to take priority. And there's a rule, a golden rule for nomenclature, hardly ever broken, that the name with priority is the first one published, which is Homocanthus imperator. So this name, Bishop I, becomes a synonym of the other one. That's how it works. It's quite simple. So simple rules about that. On the other hand, you can get a case like this, where two nice-looking fish are given the same name and thought to be the same species, but when somebody looks at them a bit harder, they find the one on the right happens to be a different species, and the differences between those are real species differences. It has to be given a new name, Heraldi, having been originally called Flavissima like the other one. It's a case of homonymy. These are just two examples of some issues which really can become very complicated if you've got more than two different candidate names. I'm sure you can imagine it. Or you've got differences of publication priority, who published first, and where, and when, and so on. So you can see that this can be very confusing. And if you get the wrong names in the literature, and particularly in this age of computers, you're going to do your sorting procedures a disservice. You're going to get into a mess. And just to show you how bad it can be, this is one particular beetle, and those are all the different names or forms in which the names have been applied over the years. If you put a search on one of those, you're going to pull up only a fraction of the total data. It's all the same animal. So you need to standardize the names for reasons which I hope will be quite obvious to you. Well, here's a quote from Bob May, who used to be president of the Royal Society, who's pointed out to us that we don't yet have a computer index centralized, computer index with all the species we know about, let alone the ones we're still adding to it. And part of the ICZN's mission is to do just that. I won't labor the point. The ICZN is essentially the quality control for all the lists and catalogues and so on that are being produced of biodiversity right now. So it's really important. The thing that surprises me slightly is that it has such a job finding the funds to keep going. You'd think it would be financed by UNESCO centrally, and the Commission tries very hard to get such funding, but it's extremely difficult to get the money for the work that we need. When you get a really difficult case, most of them can be adjudicated by a set of rules that are printed. When you get a really, really difficult case, you have to put it out to some sort of arbitration. And this arbitration is rather like a panel of judges sitting to arbitrate a particular case. And the judges in this case are the commissioners, 28 distinguished scientists from all around the world who vote on what the outcome of a particular case should be. And once that vote's been taken, it's a change in the law, and the name they vote for, it's usually a dispute between two, sometimes three names. Once it's been solved, it is accepted. It's called an opinion, which becomes incorporated into the way we talk about the particular animal from then on. So it's a very, very useful service. And I might say that everybody does it for nothing. So they use their experience for the good of science. Occasionally you get a name which can be thrown out and forgotten about for very good reason. The skull in the middle is that of Eoanthropus dawsoni, otherwise known as Piltdown Man. It was a fake. So the name Eoanthropus dawsoni is completely useless to man and beast. But unfortunately, it remains available as a name. It means nobody else can ever name anything Eoanthropus dawsoni, even though the animal after which it was named was a blatant hoax. Right, now I'm going to switch mode a little bit to talk about some of my own naming and particularly some of my own organisms. I'm going to start off, we heard from the director of the Natural History Museum earlier. This is a previous director, E. Ray Lancaster, and he's riding atop an okapi, an animal which he actually named. So he was the namer of that particular organism. But he named various other organisms. And as an example of a generic name, well, recently I was at St Andrews in Scotland, and I discovered when I was there, rather lovely story, because E. Ray Lancaster was a keen golfer, apparently. I didn't know that till I went there. And one day he lost a golf ball into the sea, which, as you see, is that's why I showed this shot. It's quite hard by. You can imagine it happening, particularly if you're me. When he retrieved the golf ball, he discovered at the same time a worm, a marine worm. And he brought it back home, and this is what it looked like. And he named it Golfingia. Which leads me on to this idea, because names are not, I mean, they're very, very useful, but you can also have a little bit of amusement and pleasure with them. So now I'm going to go on to talk about a beetle. Now, this is a little slime-eating beetle that was described by the former keeper of entomology, Quentin Wheeler, and he likes slime-eating beetles. They're small animals, and this one he called Agathidium varderi, after Darth Vader, the Dark Lord of Sith, I think. But the funny story about this particular genus is that when Quentin named it, he went on to name a whole lot of little slime mold-eating beetles after George Bush and his cabinet. So there are Agathidium bushi and Agathidium rumsfeldi and Agathidium cheney. But of course, when I actually, I drew a rather obvious conclusion from this. But when I spoke to Quentin, he looked quite affronted. And he said, "Oh, good Lord," he said, "no, I've been a Republican all my life. For me, there is no greater honor than naming a small slime mold-eating beetle." In fact, he said, "I named one after my wife." Now, I'm now going to switch to fossils, because that's what I do as a scientist, which means you lose the color. Sorry about that, or nearly all of it. This is one of the few animals that came in through the front door of the Natural History Museum as a public inquiry, as we call it. A member of the public brought it in and said, "I found this in North Wales in a quarry," you might have been there, David, "where Angelina sedgwicki occurs, a famous trilobite. What is it?" And my eyes came out on the proverbial stalks, because I realized it was an extremely rare kind of animal called an aglaspis, a distant relative of the scorpions, very primitive. We'd never found one in Britain before. So, very excited. And I wrote a scientific paper on it with my friend Adrian Rushton. Now, this man's name was Tom Unite, which is absolutely tailor-made to be a species name. So this is called now Tremaglaspis unite, or unite, to give it its Latin pronunciation. And we were tremendously excited by it. It was published, and Tom went back to his quarry and he rang us up and he said, "I've got 6 more." So we had to write another paper correcting the things we got wrong in the first paper. The things I work on, of course, are these animals, trilobites. And they'd fit comfortably in the palm of your hand. But with David here, I thought I'd show you this one. It's actually a cast, just to show you that they get to a good size. And we actually saw this one when we were working together in Morocco in making a TV program some of you may have seen. And I remember saying to you at the time, "Oi, that's a new one." Well, actually, not only new, it's the first complete specimen of the whole family of trilobites to which it belongs. And it's gigantic, well, pretty large. Unfortunately, they wanted an awful lot of money for it, the owner. And so in this case, I went to the only person I know with the kind of cash to buy something like, I'd persuade the owner, Mr. Tahiri, you'll remember him, to part with it. And Sam Stubbs came up with this money. He's a Houston lawyer, not short of a few pennies. And this is not yet published. But this too will have a binomial, a 2-word name, and I'm going to name this one quite rightly, I think, after Sam Stubbseye, who bought it for me. For science, sorry. Well, now this is an excuse for me to go a bit down memory lane, because I'm showing you the first trilobite. They're not all as beautiful or complete as the last one. You see, this is all put together. Most trilobites fall into bits. So you're now going to see some bitty bits, some bitty trilobites for a bit. The first one was this thing, a very peculiar trilobite with enormous eyes, great balloons of eyes. They normally have quite small eyes. This was the first trilobite I ever named many years ago. And I called it Opiputa. It was a new genus. Quite exciting. Opiputa, which means one who ogles, because of its great eyes. And inconnivus means without sleeping. So it's one who ogles without sleeping. That was my first ever trilobite. Then I named one for my wife, which is one of the most attractive trilobites I've ever discovered. She's sitting in the front row. But it is actually rather a lovely thing that I found in Spitsbergen. These were from the Arctic island of Spitsbergen, where I did my PhD and wrote a large number of papers describing rather wonderful animals from there. All of them new to science. Parapylechia, just to tell you, was a known genus, so the species name here is Jacquelini. This one, by contrast, I think even if you don't know anything about trilobites, you can see it's pretty boring. All smoothed out. And ossitatus, its species name, means liable to provoke a yawn. I had to go through quite a lot of Latin dictionaries to find that one. I might say that, just to talk a little bit of shop, they've relaxed the rules about Latin or Greek roots for species names recently. I'm not sure I altogether approve. I'm a bit of a traditionalist like that because I'm the only person. I did Latin at school, and for years people said, "Oh, you're never going to need that. You'll never need Latin." And I'm probably the only person really who's used it on a regular basis that I've known. This is a rather nice trilobite belonging to a whole group that I found for the first time in Spitsbergen. That's its reconstruction on the left, one of the first drawings I ever did. And this was, for all kinds of technical reasons I won't go into it, rather weird. It's a very weird trilobite. In fact, it lived in a very weird way. It lived by farming bacteria, sulfur-loving bacteria, on its underside. It was a very special animal. But because it was so weird, I called it Balnibarbi, which those of you who like the works of Jonathan Swift will recognize was one of the countries that Lemuel Gulliver visited in Gulliver's Travels. It was a country full of balmy natural philosophers. So it was a little bit of an in-joke. This relative, however, was also found in the same kind of very sulfur-rich rocks, which, of course, they used in life to harvest sulfur bacteria. But when you broke these rocks open, they were still released a tremendous puff of hydrogen sulfide, rotten eggs, so it smelt like a sewer. And cloacaspis actually refers to the Roman word for sewer, so it's sewer shield, literally. This trilobite, very fragmentary, was from Australia, which I worked on a few years later, and had a remarkably hourglass-shaped glabella, this middle part of the head here. You can see it. Even if you know little about trilobites, you can appreciate its shape. Slightly top-heavy. I call it Noracophus monroei, after Marilyn Monroe. I have managed to get back a little bit of colour, just because they're such fantastic trilobites. These are some of the chaps that David and I were looking at on the TV programme. I've talked about how beetles are being found all the time, and indeed some small mammals are still being found, but of course trilobites, perhaps not surprisingly, they've been called the beetles of the Paleozoic. I mean, you find lots of new species, some of them highly improbable looking. When this one first came into the Natural History Museum as an inquiry, again, but they wouldn't donate it, I thought it was a fake, because I'd never seen a trilobite with a trident stuck in its head before. I mean, it just looked inherently implausible, and there's no living organism that I know about that looks remotely similar. So I went with a colleague back to Morocco, where this thing had been found, and blow me down, we found 2 more species of it, with different shaped tridents. So it does give you a pretty good visual how, even if you work with fossils, you can look for the sorts of characters that were likely to have been the species characters of the animal in life. So those have 3 different species names now, coined by us. This other Moroccan trilobite has the most incredible eyes of any trilobite known to me, and one of the most incredible eyes in nature. Look at this thing, it's amazing. We're looking at sideways on now, so these are like great long towers sticking up above the rest of the animal. So I was really rubbing my hands with glee about naming this one. You can imagine it. Bilocularis, all sorts of nice names were coming to my mind. But this is just to show you can't muck around with the rules of nomenclature. Because I found, unfortunately, a tale, which you can't see on this, had been described earlier from Algeria in a really, really obscure publication. But the rule of priority means that instead of giving this a lovely descriptive name about its lovely weird eyes and all the rest of it, I had to settle for it being called Urbano-Chile, named after Professor Urban from the University of Bonn. I'm not implying anything about Professor Urban here, but I was nonetheless very disappointed I didn't get the chance to name this animal, because we all of us have to obey the rules of nomenclature. Otherwise, we just get in a terrible mess. And that's a way of kind of making a segue, I think you can call it, into David's part of the talk. Trilobites, like beetles, aren't particularly rare if you go to the right place. And I've recently been looking at a lot of these giant trilobites from Morocco, of which that one I brought along is just one example. This again is Tahiri's museum. It's a whole slab of them. They're all about a foot long or more. Absolutely spectacular. And one of these trilobites, not from Morocco this time, but from Portugal, here's a slab of them, I can recommend this to all and sundry here tonight. If you are in northern Portugal, look for a little town called Arouca, A-R-O-U-C-A, and just outside Arouca, they've got a Museo del Trilobitos. The local quarry there produces slabs with enormous trilobites. There they are. And this is just, the whole museum is full of them. And this particular animal is actually named after me. So it's Ogygynus fortei. So what you make of a large, flat, squash trilobite being named in my honor, I don't know. But David, I know, has had a prodigious number of organisms named after him, some of which you'll be hearing about later. Some, but not all of these stories, I've put together in my stories about life behind the scenes at the Natural History Museum, which may be available after the talk, at which point I think I'm going to hand you over to David. Thank you.
Perhaps I might explain how I became involved in this taxonomic business. I took a degree in zoology and went to the Navy. When I came out of the Navy, I didn't quite know what to do, and I ended up in television in the very early days. Television in that time was entirely live. Natural history programs, it consisted of getting some poor animal from the London Zoo, stuffing it in a sack, taking it up to Alexandra Palace, taking it out, plonking it on the table, and describing it. Needless to say, the animal was terrified, but there we are. It was interesting in as much as the animal, this was a live program, so it might bite the chap who was holding it, or pee down his front, which was perhaps even better, or even escape. But so it was good stuff, but it wasn't exactly zoology. And I thought that the way we had to go was that instead of doing that, we would show the animals in their natural habitat to start with. So I talked to a friend in the zoo called Jack Lester, and I said, what we want to do is to get to Africa to film you people, you practicing zoologists in the Zoological Society of London, see how you get your animals. And we could film you doing that and catching these animals. And then we could see them live in the studio after you caught them and brought them back. So Jack agreed to that. It was a good idea. And I said, well, of course, we need a title. We need something to titillate the excitement of the general public. Couldn't we have a quest of some kind? And Jack said, well, I suppose we could, yes, a quest, I suppose. I said, well, is there some animal that you've never even seen, or that we could go in search of, that we could explain to get viewers excited? And he said, Well, we would go to Sierra Leone, where he had spent a lot of time, and I said, is there no animal there that would know? He said, yes, there is one. I said, well, what is it? He said, it's a bird that nobody has ever seen alive, no scientist. And we know anything about it. We've just got the skin, but it comes from Sierra Leone. I said, wonderful. So it could be quest for this bird. He said, well, I suppose it could. I said, well, what's it called? And he said, well, it's called Picathartes gymnocephalus. And I said, yes. I mean, quest for Picathartes gymnocephalus doesn't actually roll off the tongue. Doesn't it have another name? Oh, yes, of course, it can have another name. It's called the bald-headed rock crow. Well, that didn't quite click either, so we just called it Zoo Quest. But I started the series by explaining we were going to look for this thing called Picathartes gymnocephalus, and I would end each program by saying, well, we still haven't found Picathartes gymnocephalus, but if you turn in next week, you'll see what happened next. And the series did okay. And I was traveling with the cameraman, Charles Lagos, after about program number 4 or something, down Oxford Street in his open red sports car, because you could go down Oxford Street in those days in cars. And we stopped at a traffic light. And the bus driver, alongside, pulled his window back, and he looked out, and he saw us sitting in this car, and he said, hello, he said, are we or are we not going to find Picathartes gymnocephalus? So I concluded that we're not doing too badly. There we are. There's Jack and me. And we were, after some time, we went around showing pictures of this bird to the local people because it had no name. We didn't know the local name. But they recognized it. And Jack, we found the nests on the underside of a great big rock. That's old Jack. And eventually we caught one of these little creatures, and we brought it back, and it was the first time it had ever been seen alive in the Western world. So the bus driver got fulfillment in the end. And now, of course, it's well properly documented, and a very interesting bird it is. But this business of finding names for strange unknown animals, of course, has a very long history. Back in 1799, this extraordinary thing turned up at the Natural History Museum just down the road. And it's an odd thing, as you can see. It's got fur, like a rabbit, but at the left-hand side there, you can see it's got a beak, like a duck. And if you could see the right-hand side there, it's actually got webbed feet. It was shown to the zoologist, keeper of zoology, in the Natural History Museum, and he naturally thought it was a fake. There were a lot of fakes in those days. But he couldn't see any way that it was joined together, so he concluded that it was actually a real thing. And he called it Platypus anatinus, 1799. Dr. Shaw did it. Platypus means flat-footed, and anatinus means like a duck. Not a bad name. But, unfortunately, platypus turns out to be the name also earlier of a little beetle. And a specimen had also been sent to a Professor Blumenbach in Göttingen. See, and he said, "Ah, no, this cannot be. This cannot be platypus. We must think of something else because of the beetle." So he called it Ornithorhynchus, which I must say is actually probably a better name in that it means an animal with a beak like a bird. So, in fact, the first published account of the platypus was in a book published in 1802 written by the secretary to the governor of New South Wales, Mr. Collins, well, Lieutenant General Collins, in fact, or Lieutenant Colonel Collins. And he His first book came out, first volume came out in 1798. And for his second volume, he sent the manuscript across to London. And in it, he described the animals of Australia. And he obviously wanted to describe this strange thing, which he then himself thought was called platypus. But it was printed, that book was printed in London, and it was just in time for the printers to put the proper name on the top of it, which was, of course, Ornithorhynchus. So the fact of the matter is, though, that ever since then, you, me, and everybody else who wants to talk about the animal in a non-scientific way still calls it a platypus. But the fact is, scientifically, it has to be called Ornithorhynchus paradoxus. Now, the business of finding names, of course, becomes very acute with fossils, when you're discovering fossils that have not been seen by people before. And the great glory period of fossil collecting in this country was in the early 19th century, and it was this extraordinary lady, Mary Anning, who lived in Lyme Regis, born in 1799, and when she was 12, her father died, and it was up to her and her brother, she was aged 12, to find a means of supporting her widowed mother. And she found ammonites, which are very common in the Jurassic rocks of Lyme Regis, as lots of people here will know, and started selling them. And she started making a living that way. But she was a very, very clever lady. And she didn't just find shellfish or cephalopod shells like ammonites. She also found bones. And soon she revealed to the learned gentlemen, clergymen, country landed gentry, scientists, coming down to Lyme Regis, where all these things were being discovered. And she supplied these fossils to these learned gentlemen who interpreted them, I must say, I think pretty sure, with a lot of help from Mary. And so it was revealed in the middle of the 19th century that during the Jurassic period, there were these extraordinary things, great reptiles swimming in the seas. The ones that were looking like fish became called ichthyosaurs. But there were also longer things like that, the ichthyosaur on the right with big teeth, and then the other ones with long necks and a smaller head, as you can see, being eaten by that ichthyosaur, which are called plesiosaur. Now, the word saur, of course, means lizard. Ichthyosaur means swimming, a fish-like lizard, and plesiosaur means almost like a lizard. And, yeah, there you are. And the biggest of these she ever found was this one, which is 7 meters long. It's a plesiosaur. And it was sold, a public subscription, and it was named Plesiosaurus Conybearii after the Reverend Conybeare, who was the vicar of Axminster, and was a great enthusiast for these things. And Plesiosaurus Conybearii became one of the most spectacular exhibits in Bristol Museum. And there it is, beautiful and wonderful thing. And in 1940, Hitler dropped a bomb on Bristol and destroyed it. But there was another cast which was in the Natural History Museum. Now, one of the problems that paleontologists like Richard and many others face is that bits and pieces, animals turn up, particularly big animals, in bits and pieces. So you'll find a head here, and you find a paddle there, or a leg there, and you each give them different names. So after you've been doing this for a long time, paleontologists agree that one particular expert man will look at the whole lot and decide whether, in fact, they belong together, so there only should be one name and not 3, and generally revise the genus, as it's called. this job was given to a man called Robert Bakker, a very distinguished reptilian expert living in America. And one day, I went in to the Natural History Museum, and Angela Milner, who has a special responsibility for Archaeopteryx and dinosaurs in the Natural History Museum at the time, happened to be coming out. And she said, many, many congratulations. I said, really? What? She said, well, your plesiosaur. I said, my plesiosaur? Oh, yes, she said. Bob Bakker has revised the whole plesiosaur family and has decided that one of them, to wit, Plesiosaurus coniberi, is so different from all the others that it's not a plesiosaur at all. It should be given a new name. And he's called it Attenborough coniberi. And I said, you can't be serious. She said, yes. Now, Bob Bakker, who I've met once, had never consulted me or asked me about this. However, I thought I must write to him and thank him for this great honor, for indeed it is. And so I wrote to him and said how wonderful this was, and thank you very much. And I said, and as a matter of fact, I often go down to Lyme Regis, where it was found, so it'll bring a whole new meaning to the phrase of taking a couple of weeks off trying to find myself. But I never did. I never found it. However, it meant that here was my great scientific glory with a name after me, but unfortunately, it didn't exist in reality because it was just a plaster cast. The real thing was destroyed. And so I said to Angela, do you mean to say that you've changed the label? No, she said, we've had the vote for our allocation, our budget for the redecorating of that gallery, and that's just been spent, so I'm afraid we can't change the label. So my moment of glory was that I had named after a fossil that didn't exist and didn't even have the name up underneath its past. However, in fairness, I have to say, the Natural History Museum have rectified that. So there it is, Attenborough. However, I thought, I haven't really quite achieved glory yet because, it doesn't exist, And then an old friend wrote to me called Tim Flannery, who was, I knew an Australian, I knew in New Guinea. And Tim said, I've just been working in the museum in Leiden. And Tim is an expert on the mammals of New Guinea, and including this particular one, which is an echidna called Zaglossus, this generic name. And he had found a Zaglossus in the museum in Leiden that had been collected back in the 60s. And he decided that it was actually different from the Zaglossus, which I showed you. So he said, we're going to call that Zaglossus Attenborough eye. I said, really? It's really, the fame is coming at last. No, he said, I'm afraid not. As far as I know, it's extinct. So once again, I am thwarted, though there has been expeditions to look for Zaglossus Attenborough eye, but as far as I know, they haven't yet found it. However, back in the late 70s, early 80s, I made a series about the history of life on Earth. And one of the key moments in the history of life on Earth is a moment when fish with backbones but no jaws, but heavily plated fish with armor plating, evolved into two other kinds of fish, one with lobe fins, which became our ancestors, and one which became other simpler fins, which became teleos fishes, which inhabit the ocean today. And the key place where the evidence for that was in the middle of Australia, and it was found by people from the Natural History Museum down the road. And it's on a strange, Central Australia, a huge cattle station called Gogo. So when I went down there to film doing this program, I said to the Australians, we would like to go to Gogo. And he said, why do you want to go to Gogo? And I said, well, it's the great place where all these fossil fish were found. He said, yes. He said, yeah, you Poms come over, you take the easy stuff, and you take it back to your museum and you give it fancy names. But you've done that, and now we've had to go in and do a proper job, and I can assure you there's nothing there. So I said, well, that's very kind, but I would like to show the site to see just where these boulders were, and which contained these fossil fish, and where the reefs were. And after a lot of negotiation, it was agreed that we could get a helicopter and go to Gogo Station. And the Australian expert who was responsible for giving us permission came with us. And I stepped out of the helicopter onto this, we landed in there, and I put my foot on a boulder. And on the boulder, there was a rectangular scute. These were armored fish. And on the top, you can see these bony plates, which give them their armor. And on the top, there's a rectangular one. And I looked at this, and I said to the Australian, I said, what is that? And he said, you bastard. But he was decent enough to let me keep it. So the next part of the story becomes, after that account, becomes a little more exciting, because only a few years ago, I got a letter from an Australian paleontologist called John Long, working in Victoria, and he had found and reworked some of these Gogo specimens, and he had discovered something quite extraordinary. He discovered that one of them, there's the specimen on the top. Unfortunately, it's reversed, so that you can't, so if you have to do a comparison along diagonally, as it were, he had discovered that extraordinarily, at this very early period in the history of life, these armored fish had stopped laying eggs, as everybody thought they would, and actually bore young. Not only that, but it had an umbilical cord. Remarkable, astonishing. This is 370 million years ago, that sort of thing. And at this very early period, the animals, the fish, the vertebrates, were live bearers. And this is what they think they looked like. Here you can see this strange fish, and you can see the baby just emerging, and alongside, trailing behind it, is the umbilical cord. Fantastic. And John Long was kind enough to write to me and say, we would like to call this Mater pisces, that is mother fish, Attenborough eye. I said, that's amazing, thank you very much. And then I thought, of course, if you have internal fertilization, you must actually copulate. This is the first known example of any vertebrate copulating in the history of life, and he names it after me. So this has been a source of some concern to me. Giving these names, of course, you have to do it as soon as they arrive, as soon as a specimen turns up. And back in the 16th century, when Magellan came round from, his expedition did, he died on the way, when they landed in Spain, they brought with them extraordinary things, of which that is a drawing. And it is a bird, as you can see from the beak at the top, and it has these plumes coming down from its side or its rear end, but it has no wings and it has no legs. And people said to Magellan's sailors, how come? I mean, what sort of animal is this? And the sailors said, well, we got it in the East Moluccas in eastern Indonesia, and we asked the people exactly that question. And they said, well, these birds never have wings, and never have legs because they live in paradise. And they float in the air, feeding on dew. And human beings only find them when they fall to the earth. And so they are called birds of the gods, birds of paradise. And English, not European naturalists, thought, gosh, how extraordinary, and they called them birds of paradise. Of course, it didn't last for long. I mean, some naturalists said, come on, go up, it can't possibly be true like that. What has happened, of course, is that the wings have been cut off and the feet have been cut off simply to emphasize the glory of these wonderful plumes. And so after about 50 years, you find that the birds are represented with legs. Nonetheless, Linnaeus, of whom we have heard and pay respects to, Linnaeus, when he came to draw up the great catalogue, his Systema Naturae, his great catalogue of the natural world, he called it Paradisia apoda, the bird of paradise without legs. But his tongue was in his cheek, I'm quite sure. But nonetheless, today, still, we call it Paradisia apoda. And it's part of the delight in natural names that they carry history with them, and the history that is in that name. Subsequently to him, well, that is Paradisia apoda, and you can see it certainly has feet. But we all delight in calling it the legless bird of paradise. But as centuries passed, expeditions after expedition went to New Guinea, and they found more and more and more members of this astounding family. And the 19th century explorers, particularly, there's one particular one, D'Albertis, an Italian, he found a lot of this. He called this one, with red plumes, not yellow plumes, he called this one Raggiana, after Count Raggi, who was a great friend. But later explorers began to realize that if they wanted to finance their expeditions, here was a chance of giving immortality to people who had a little money, maybe. So, when they found something like that, they called it Prince Rudolph's bird of paradise, after Prince Rudolph of Austria-Hungary, who was later to commit suicide in the Mayerling tragedy, but hoping that Prince Rudolph would give some money to his expeditions. Not only that, but this one became the King of Saxony bird of paradise. And whether the King of Saxony gave money to New Guinea exploration ornithologists, I do not, in fact, know. But I do know that giving names to species, names that will be revered and bandied about through scholarship for years to come, is an attractive idea which does occasionally produce ideas from people who have money to help in the process. And I'll pass to Richard to explain how that might happen. Thank you.
Well, this doesn't really belong to me, this extraordinary creature. This is really to emphasize the fact that you can still go out into the world and find extraordinarily new beasts which will require names. And in fact, George McGavin's here, and he will probably like to say a few words about this animal, but it was recently discovered in New Guinea. And when I first saw this, my eyes really did widen because, you know, I know what an ant looks like. The only trouble is that when you look at its face, it's not an ant at all. It's a spider. It's a jumping spider producing an extraordinarily accurate mimic of an ant. Well, one of the points is, a general point that David was alluding to, is that we are now, of course, in a biodiversity crisis, as everybody knows, and people interested in nomenclature, like everybody else, are interested in halting this terrible process of extinction before things even get the benefit of a scientific name. Most of us regard it as an extraordinarily serious matter. And the question is, what extent you might name something after somebody who contributed in a material way to perhaps saving that species, or in the case of the trilobite, acquiring it for a public collection. The point about everything we've been talking about, David's specimens, my specimens, is that they should reside, and all name bearers have to reside, in a public museum for safekeeping, for perpetuity. The day of the private museum really stopped many years ago. So you do require public-spirited people to present their collections and maybe contribute in a financial way towards saving species, which, if they do enough, they may even finish up being immortalized by having a scientific name after them. I think that's probably a good point at which to stop and take your questions.
David and Richard have agreed to take questions. Given it's not always practical to get a microphone to you, what we agreed was if you would shout your question out, I will repeat it for our speakers, or try to, and they will give a response. So have we got any takers? It's always a while to get the first question. Down here, sir.
I may be the only person in the room who doesn't know is, how do you define a species?
How do you define a species?
How long?
Well, as a biologist, David,
Yeah.
there are practical ways of defining species, and there are morphological ways of defining species. There's a formal definition of a species, that a species is an organism that is capable of reproducing within its population and reproducing, we'll say, animals of its own kind. In other words, breeding is the criterion for a species. But for most practical purposes, for zoologists and indeed for paleontologists, because we can never know if they could interbreed, it's a morphological definition. Of course, nowadays we have the addition of DNA evidence, which is becoming more and more crucial, which is a different way of asserting identity. And a lot of modern work is done almost immediately. You go from the specimens in hand to looking at their DNA in a lab, which contributes other information. I hope that's a direct enough answer for you. David?
There's just one thing you could add, which is that it is often said that species don't interbreed with other species, because if they did, there would be one population and the differences would breed out. But of course, there are species which can interbreed with other species. Lions can interbreed with tigers. They don't necessarily produce fertile young, but in some cases there are these things, but they do not naturally occur in the same place. But having said that, modern biology is recognizing that the 19th century notion of a species actually has fuzzy edges, because species do change and species do emerge from other species. So that process isn't an overnight flash. It is a gradual process. So it follows that there will therefore be fuzzy edges where you can't be quite sure what it is. Nonetheless, if you don't have some labels, even for parts of it, even if you acknowledge that the edges are fuzzy, if you don't have any labels at all, you're really sunk. I mean, you have nothing to talk about.
Anybody else? A shy, retiring lot we are tonight.
There, I can see.
I can't see. Oh, yeah, sorry.
What was the Attenborough galaxy named after? A bird, a fish, a mammal, or a reptile?
Did you get that, David? What would you like to be named after? A bird, a fish, a reptile, or an amphibian?
If to be quite truthful, I think it is a bit embarrassing to be named after anything. I have to say, and I suspect that the ideal names are not named after people. The ideal names describe some characteristic of that creature, which is distinctive. It could be the fact that it has a lot of horns, or it is hairy, or it is small, or it is ferocious looking, or something like that. But you do run out of names after a bit of those kind of adjectival names. So then people use it to pay compliments to one another. At least I hope they are compliments.
Anybody else?
There's one.
Down here, down the front.
This is probably a question that a lot of people are asking, whether or not we'd like to see the programme from David anything soon.
David, are we going to see another programme from you?
From me?
From you.
I've just come back from Madagascar, and we've been filming wonderful creatures there called lemurs, which are kind of a very early form of primate. They are most beautiful creatures, but also we've been filming, there was a huge fossil bird that's the biggest bird that ever lived, like an ostrich, only very much bigger, laying huge eggs, which is called the elephant bird, and it's source of a legend that was brought back by Marco Polo, that there was a bird somewhere in the Indian Ocean so big they could pick up an elephant in its talons. I was in there 50 years ago in Madagascar filming, and I've gone back to look at what's happened in the last 50 years, but also to trace up the origin of that particular big egg, one of which I found when I was there 50 years ago.
Down here, George.
One thing, obviously, is that we're losing habitat at an incredible rate. And although we've named 1.8 million species on Earth, we're pretty sure there are between 5 and 10 million. Will we ever name everything on Earth? Is that a forlorn hope?
Will we ever name all of the species that are out there?
No, I mean, of course, well, it's really Richard's question, but the process of identification, as you well know, George, is continuing, and the more expert it is, the more clever you are at distinguishing creatures that you once thought were the same. And even if there were no completely new things to be discovered, we would, I suspect, go on looking at our connection. Because after all, a visual assessment of an identification of a species is only one characteristic. And we know perfectly well that animals can come together and with convergent evolution and come to resemble one another very closely, which is where molecular biology comes in and the molecular fingerprinting or identification of species from living tissue. And I suspect that as history goes, well, I shouldn't be talking about this because they're experts here, as history will go, they will discover that a lot of things we thought were one species are, in fact, if not two or three.
Yes, that has happened. But I mean, there is an important point here, which is that identifying new species, naming them, describing them, as we say, is an expert business. And what we're losing globally is experts. The kind of people who do this job are known as taxonomists, and they're getting fewer in numbers. I mean, Michael will confirm just what problems we're having at the Natural History Museum, trying to keep our numbers up. The web helps because it facilitates very rapid communication around the world. So perhaps you don't need as many experts as you once did, but by golly, we need them. And in a situation where things are going extinct, you won't necessarily have an expert left who can actually say this is a new species for whole groups of organisms. And that, I think, is extremely disquieting.
Gentleman down the front here.
Fortey, you talked about, in life, in your book, you talked about your expedition to Spitsbergen and the joy there, and today you talked about going to Gogo, and as somebody who's recently discovered the joys of travelling, I want to know your favourite place you've been to.
The favourite place you've been to?
So, favourite places? The next one.
And Richard?
Well, yes, it's difficult to make a choice. But I would say that I like deserts for some reason. And I've worked in some wonderful deserts in Oman and in Nevada and even in the middle of Australia. But I'm not quite so young and adventurous as I once was. And particularly, funnily enough, the centre of Australia was also quite scary. I was further away from anybody there I've ever been ever. And I'm not sure I'd like to go back, but it's wonderful to look back as a memory.
Right at the back there.
I was wondering what your opinion is about the renaming of fruit flies, recent renaming of fruit flies.
What's your opinion on the recent renaming of fruit flies?
You're named after a fruit fly? You ought to tell one of your stories about some of these little fish, but go ahead.
I know what you're referring to. All I can say is that you're referring to Drosophila melanogaster, which was a well-known name, and the Commission, in their wisdom, has decided that this is one of the standard experimental flies. And a whole group of entomologists have decided that it causes less confusion to rename this well-known fruit fly, Drosophila melanogaster, than rename, I think, Eleanor, remind me, 400, is it? You'd have to rename 400 species to maintain that one well-known one. So I can't comment on the details of it because I'm not that sort of entomologist, but that's the way the decision came out.
Gordon?
Am I right? Wasn't there a new species found in the Natural History Museum? I mean, not in a cage or in a box, but actually living.
In the wildlife garden.
Haven't found any more, and are there more to be found?
I'm sure there are. I think the case you're referring to is that the curator of beetles in the museum has a very young son who found a new species in the wildlife garden. So there are new species out there and some not very far away, and I'm sure there are more out there.
So he's going along this.
So you don't have to go on big expeditions. Absolutely. Perhaps I might take the opportunity to expand on Richard's story about Quentin Wheeler and the slime mold-eating beetles named after the US president. Quentin was in his office one afternoon and the phone rang, and an American voice at the other end said, "I've got the White House on the line. The president would like to speak to you." And indeed, George Bush did come on the line, and in fact he was delighted that he'd had a species named after him. So it only goes to show, doesn't it? Are there any more questions? Down the front here, and then.
So DNA barcoding will replace traditional taxonomy, and if so, is it a good thing or bad?
Will DNA barcoding and molecular analysis ever replace morphological examination? And is that a good thing?
I think both methods have to be used to reinforce one another. We have extra tools to be extra precise, and it would be foolish to throw away any one tool that we have. And you have to use the results by using both tools to get to coincide.
Well, I would add to that only that it depends on your organism. I mean, some sorts of organisms, flatworms and things like this, nematodes, are very hard to characterize morphologically. And the DNA barcoding techniques have speeded up identification of species. Very often they're not formally named. Then, as you probably know, they become a record with a particular barcode. But it's no substitute for giving them a Linnaean binomen with which you can communicate with other people. And of course, the name is only the first step. Most of the interesting, what I call the biography of a species, has then to be expanded when you observe the creature in the wild or try and deduce its life habits if it's a fossil. The interesting stuff lies beyond. The barcode is useful, but it's not the end of the story. It's just the beginning of the story.
2 rows back there.
Across the world, lots of indigenous and other cultures have different names, folk taxonomy, as it were, for different species and animals. Are they often accurate, or relatively accurate, or how far are they taken into account in the scientific?
Is folk taxonomy, the names that indigenous peoples give to animals, taken into account And is that often accurate and relevant?
I don't know, Richard, can you?
Well, I can think of one story. In the old days, nowadays we have rather stringent requirements about making a species validly proposed. You've got to say how it differs from other species, and you've got to illustrate it, and you've got to have a description which goes into a lot of detail. And you've got to have type specimens, so-called, which reside in a museum, which has free public access. You've got to do all of that before your species is valid. They weren't so stringent in the old days, but there was a rule made, one of the rules of taxonomy, that before a certain date you could accept rather brief descriptions. This does come back to your point. A friend of mine was telling me about a fish, the description of which was, this fish is much revered by the Arabs. And that was all. So, presumably, in order to identify this fish, you'd have to take it to the village, present them with a series of fish, and say, which one do you revere the most, in order to identify it. But certainly, I mean, Aboriginal peoples are very well known for accuracy in identifying species they can eat or which they can use. And it's a foolish naturalist who doesn't pay attention to indigenous people.
Okay, up there in the balcony, apologies, with the light in my eyes, I couldn't see you.
What's the scariest animal have you ever seen?
That's a good one. What's the scariest animal you've ever seen? Both of you. See if they're the same.
To give you a serious answer, I think there is one animal which I've never met, but I am sure I would be very, very scared by, and that is the king cobra. The king cobra grows to about twice the length of a human being, goes about 12 feet. It rears up and can rear up as high as you, and I am told that it will attack without provocation. There are very, very few animals in the world, in my experience, that attack without provocation. And this king cobra does. Not only that, but it makes a noise, a sort of grunting noise at the same time. It brings me out a cold perspiration just to think about it.
And Richard?
I know the one that gave me the biggest fright when I was working in the Oman desert. Everything goes to sleep during the day. It's so hot. And I was collecting trilobites, you'll be amazed to hear, from slabs of rock that were lying around the place, and you had to lift them up with your geological hammer like this. And one of them I lifted up, and there was a small grey snake underneath, all curled up, that shot across the desert. When I got home, I said, "What was it?" to our herpetologist in the museum. He said, "Oh, that was the asp that probably finished off Cleopatra." But I wasn't scared of that. The one that really gave me a turn was when I lifted up another stone, and a very large black scorpion came scuttling out in my direction with its sting held aloft. And I sort of took 5 steps backward and went, ah. But at that point, my Omani hosts came up and said, "Oh, don't worry about that one. It's not particularly dangerous." So I then lifted up another stone and said, "What about that one?" And underneath this particular stone, there was a small scorpion with a sideways slung sting, if you see what I mean, orange in colour. And they all went, "Ah!" It looked half as dangerous, but was far, far more dangerous. So I guess that's the scariest one I've actually encountered, although I didn't know it at the time.
Okay, we've got time for maybe one more. Right at the back. We'll make this the last question.
Richard has mentioned that we're probably losing experts, but in this day and age, biology seems as so medical-oriented. How would you get young people interested in actually studying biology, taxonomy, this kind of seemingly boring stuff?
Did you get that?
I I got some of that. Apologies, I didn't get all of that. I think the gist of the question was, how do you get young people inspired and wanting to go into this field of study, rather than going into medicine?
Well, in my experience, every single one of us starts off inspired by curiosity for the natural world. I had a young friend, I took a 6-year-old into a field in Oxfordshire, and there was a stone in the meadow, and he lifted the stone and he said, "Oh, look, what a treasure, a slug." And of course, he's right. You know, it is a treasure. Those tentacle things with eyes on the end that move. How does it move across the ground? What does it live on? And so on. We all have that curiosity inbuilt. Now, as we get older, we see more things and get excited in more things and so on. And I dare say that some of us lose sight of that initial excitement. All I can say is that if you do lose that, you have actually lost one of the greatest delights and pleasure in your entire world and life.
And I will,
Richard?
Well, here, of course. But I will just say just one sort of serious point there. A lot of funding is directed towards organisms of medical interest, a disproportionate amount of funding. And I would love to see more public support for, what should we say, research on organisms because they're interesting, rather than what us human beings happen to be able to get out of them as a cure for cancer. It seems to me an extraordinary, as usual, anthropocentric view of natural history. So I'm with David. Teach everybody to really feel how wonderful nature is.
And if I may be permitted to answer the question, I think it's about inspirational role models, and we've had 2 of them here tonight. Would you join me in thanking them very much?